All right, sorry this one got split across two videos there. We're going to keep going with this next one though. So we want to know the probability of at least, and I think at least are the trickiest ones. So the probability of at least 2. That's 1 minus the binomial CDF. There are 7 businesses. The probability is 34. Here's one of the tricky parts. You don't just put the 2 there, you put 2 minus 1. It's always minus 1 on that. Whatever we have, minus 1. Another tricky part is typing it in. If you have the smaller calculator, you can't do the whole thing at once. You have to get an answer for the binomial of the CDF. Then do 1 minus your answer. So get the decimal, then type in 1 minus your decimal. If you have the larger calculator, you can type it in all at once. But you do want to practice this. And we type this one in. My goodness, my pad's going crazy today. When we do type this in, we're going to get 7487. Again, if you're using the smaller calculator and you're not getting that, make sure you get the decimal and then do 1 minus that decimal. So you should, when you type in the binomial, you should be getting something like 0.2513. Then 1 minus that. All right, let's look down at example 5. I want you guys to try it, but before you really get going with it, none is the same thing as exactly 0 on there. So I want you guys to read through this, see if you can set them up, and then we'll go over it. So go ahead and hit pause and give this a shot. All right, coming back from the pause, I told you this was going to be exactly 0. So exactly is the PDF. We were choosing 10 students at random. Their probability was 0.113 and we wanted exactly 0. Typing that in my calculator and rounding to 4 decimal places, I get 0.3015. The probability of at most 3, at most is going to be the CDF. At most 3, I'm choosing 10. The probability is still 0.113, and I'm choosing 3 of those. Typing them in, I get 0.9805. All right, like I said, I think the trickiest one is the at least ones. A lot of times people forget that 1 minus the binomial CDF. There's still 10. The probability is still the same with at least 5. Write that there. Remember my number, I'm always going to subtract 1. So I'd actually put a 4 there. So it's not the straight number all the way across. And that's going to be real tiny, 0.0028. All right. We've got one other thing to go over in this section that deals with binomial distribution. This is going to go over the mean and the standard deviation. These formulas are going to be true when we're dealing with a binomial distribution. It's not going to be true when we're dealing with other types of distributions that we're going to see in the next chapter. So very specifically just for this binomial distribution. The mean is the average. If I were going to find our class average, I would take all the grades, like all maybe exam 1, and I would divide by however many students are in the class, and that would give me our average. The standard deviation can measure how far away from the mean you are. So if I were to take one student out of the class and I wanted to compare them to the average, I could measure if they were above or below in standard deviations. And we'll get to see standard deviation and mean in more detail in the next chapter. Our N and P we've been using, and remember Q from way back at the very beginning of the section, Q is our failure. So it's going to be 1 minus P on there. So we've actually seen all of these before. So in example 6, I gave us N and Q. So I need to find P. So I'm going to do 1 minus 0.7. That's going to give me 0.3. And that's always going to be the case. You got to find the missing one. I gave you one, you got to find the other one. So this is mu, it means the mean, is going to be n times p, and that's going to give me 12. The standard deviation, that's a sigma. That's going to be our first standard deviation. It's going to be the square root of 40 times p, which is 0.3, times q, which is 0.7. I'm going to type that in, and it said to the nearest tenth, so I'm going to get 2.9. Our last example here is going to work really similar, so go ahead and hit pause and see if you can figure it out. You need to know what n, p, and q are, and then you can figure out the mean and the standard deviation. So hit pause and give that a shot. Coming back from our pause, we took 4 free throws. We made them 80% of the time. So that means we missed them 20% of the time. So the mean is going to be 3.2, nearest tenth. And these are free throws. That was my cat, if you're wondering. He's helping me make the videos. The standard deviation, multiplying those, rounding to a tenth is going to give me 0.8 free throws.